Hey guys, today we're going to learn how to solve quadratic equations. So anytime you have a question that is involving a quadratic equation, the question may ask to find the zero, the root, the solution, the x-intercept, or the answer. Okay, it all means the same thing. Okay, we're finding where the parabola crosses the x-axis. Okay, so, and we'll find out that you can have either, the parabola can either cross in two locations, like it does right here, or we could have a parabola that actually never crosses the x-axis like that. Or we could have a parabola that comes down and just crosses at one point like that one. Okay, so we can have either no solutions, one solution, or two solutions. Okay, so the first way we're going to learn is by factoring. So last unit we learned how to factor a quadratic equation, and after factoring we have two factors that are multiplied. All we have to do is set those factors to 0 and solve for x. So when we do that, x plus 3 is equal to 0, we will find that our x is actually equal to negative 3, and if we set x minus 5 equal to 0, our x would be equal to 5. So our solution set would actually be negative 3, 5. And notice these are curly brackets. It's not parentheses. It's not an ordered pair. It's saying that there's two values of x that would satisfy and set the output to be 0. And we're using the zero product property. So in this case, we said our x would be equal to negative 7. And in this one, it would be x is equal to negative 12. Okay, so we're just setting each of the factors equal to 0, and we would write this as negative 7 and 12. Okay, for number 2, our x would be equal to positive 13 and positive 25. Because if we set 13 here for x, 13 minus 13 is 0. Once one of the factors is 0, the whole answer is 0. Okay, number 3, 2x plus 3, if we set that equal to 0, okay, 2x plus 3, our 2x is going to be equal to a negative 3, and then we divide by 2, and our x is equal to negative 3 halves. So our first solution, our x is equal to negative 3 halves, and then the second one, if we have x minus 5, then x minus 5 is equal to 0, so our x would just be equal to 5. So we would have our two solutions there. Okay, moving on, we can actually graph the equation and look at our graph using our calculator. If you click on the y equals button, and then you put in the equation x squared plus x minus 6, and then you hit graph, you will actually see a graph of the parabola, and you can actually see where it crosses at 1, 2, 3. This is at negative 3 and then positive 2. So you can actually solve it. It's a lot easier just by looking at it if it crosses at a whole number. So x squared minus 36, if you graphed it, you would see it crosses at negative 6 and also positive 6. Okay, but either way, you could have actually factored each one of those and determined the solution as well. Okay, so if the equation is not already factored, you must factor first. So in my first example, okay, what we learned from last unit, if you take 6 times 1, you get 6, and then you have a 7. Okay, so in order to get 6, we're going to factor it. We've got 6 and 1, divide by our leading 1, and we have 6 and 1. So when we factored it, we have x plus 1 and x plus 6 is equal to 0. So if we set each of the factors equal to 0, our solution is going to be x is equal to negative 1 and negative 6. So that's what our solution would be, or our roots would be. Okay, for number 6, I'm going to have you guys pause the video here and try 6, 7, and 8. And when you come back, you can play it. So we should have had 18 and negative 9. You would have negative 6 and negative 3. So when you factored it, you would have x minus 6 and x minus 3. And when we set that to 0, we realize we can have our solution set would be 6 and 3. Or 3 and 6. You really want to have the answers in numerical order. So 3 and 6 would be the best answer. Number 7, okay, if we factor out the greatest common factor first, that would be a 5x. And then we're left with x minus 8, and we want both of these factors to be 0. So if we set 5x equal to 0, and then x minus 8 equal to 0, we're going to get the solution of x is equal to 0, or x could be equal to 8. So we would write that as 0 and 8. Okay, and then number 8, when we factored this one, if I did my x, I've got a negative 20 and 8, and I could do 10 and a negative 2, divide by my 1. So we've got x plus 10, and we've got x minus 2 equal to 0. So to set each of these factors to 0, x plus 10 equal to 0, we're going to get x is negative 10. And if we set x minus 2 equal to 0, x would be equal to 2. So our solution set would be negative 10 and 2. All right. If the equation is not already set to 0, then you must set the equation equal to 0 and factor. So all we're going to do here is set this to 0. And when I factor this one, I'll get x minus 3 and x plus 2. Okay, so then when I do that, or actually, let me go back here. I didn't realize that I actually had to, I missed the equal sign here. So see how it's x squared? So we're going to bring the 5x to the other side. So negative 5x plus 6. And that's going to be equal to 0. We need to rewrite it first. Then when I do my x, I've got a 6 and a negative 5. Okay, with my 6 and negative 5, I've got a negative 3 and a negative 2. Divide by my leading 1. So I've got x minus 3 and x minus 2 equal to 0. All right, so when I solve that, x minus 3 is equal to 0. My x is 3. And if I set my x minus 2 equal to 0, my x is positive 2. So my solution is x is 2 and 3. Number 10, when I bring the x to the other side, we've got 2x squared minus 7x, and then we're going to bring this negative 3 to the other side, so by adding 3, and we're going to set that to 0. Okay, when I do my x here, 6, and I've got a negative 7, so negative 6 and negative 1, I don't forget to divide by my leading coefficient. So when I factor it, I've got x minus 3 and 2x minus 1. Okay, I want to set those to 0, so x minus 3 set to 0, our x is 3, so there's one answer. And the second one, 2x minus 1 is 0, so my 2x is going to be equal to 1, my x would be equal to 1/2. So my solution would be 1/2 and then 3. Okay. Now we're going to go into solving equations by quadratic formulas. So not all of our quadratic equations are factorable. If they're not factorable, you can use the quadratic formula. The quadratic formula should work for all problems. So you don't want to just try to factor it and say your answer is prime. If you get prime, then you're going to need to try to use a quadratic formula. Okay, so if I looked at this one, I first want to identify, we put the quadratic in standard quadratic form, which is ax squared plus bx plus c, and we identify the a, the b, and the c. The a in this case is 3, the b is negative 4, and the c is going to be 5. Okay, so I'm going to go ahead and quickly do this to start out. This is the first step. Our a is negative 2, b is negative 6, c is negative 7. So that should have felt pretty easy. Okay, from here, we're going to take these values. Okay, we're going to try more. So let's try 11. Oops, that's actually a duplicate. So let's go to next page. Come on. Okay. Okay, so we're going to actually use this quadratic formula. Now, this quadratic formula is going to be given to you in a formula sheet. So you don't have to memorize it. It's good if you do, though. And I'm going to break it down for you and show you how to do this. But before we do it, I'm going to skip this very first example because I found that the first example is a little more complicated. So I'm actually going to jump to the second example, and then actually we'll start with the first example, but then we're going to, no, let's go to the second example. Okay, second example, identify my A, my B, and my C for starters. So again, let's write at the top here that our x is equal to negative b plus or minus the square root of b squared minus 4ac divided by 2a. Okay, so my A is going to be equal to the coefficient of 1. My b is negative 3. My c is equal to 2. So if I have negative b, my b is negative 3, so I would have a negative 3 plus or minus the square root of b squared, so negative 3 squared, minus 4 times 1 times 2. So my 4 times my a is 1, my c is 2. all divided by 2a, so 2 times 1. Okay, so a negative 3 is positive 3. And we say then plus or minus the square root of negative 3 squared is 9. 9, and then I would multiply 4 times 1 times 2. 4 times 1 times 2 is 8, so 9 minus 8. And that's what's inside of the radicand here. It's actually known as the discriminant. Okay, and then we're going to divide by 2. All right, so this becomes, then I say 9 minus 1 is 8. 9 minus 8 is 1, rather. 3 plus or minus the square root of 1 divided by 2. Okay, and now the reason we have this plus or minus is because if you think about it, the square root of 1 is actually 1 and negative 1. It's two answers because you could take negative 1, multiply it by itself, and get 1 as well. So right now we're actually going to branch into two answers. We're going to say 3 plus 1, so positive 1 divided by 2, and then we have 3 minus 1 divided by 2. Now keep in mind that we took the square root of 1. We happen to get 1. It's not always the same number that's under the square root. It's just that the square root of 1 is 1. So 3 plus 1 is 4, and 4 halves is equal to 2. 3 minus 1 is 2, and 2 halves is equal to 1. Okay, so we're going to try number 15. We identify our A, B, and C first. This is helpful. A is 1. B is 2, C is negative 3. Okay, so when I say, when I look at my quadratic formula, I have negative B, so I have negative 2 plus or minus the square root of 2 squared minus 4 times negative 3 divided by 2 times 1. So I've got my negative 2 plus or minus the square root of 4 minus a negative 12, so 4 plus 12 divided by 2. This becomes negative 2 plus or minus the square root of 16 divided by 2. Now 16, okay, you can take the square root of 16 and you get 4, or you get negative 4. So this is going to be negative 2 plus 4 divided by 2. This is where we branch. And negative 2 minus 4 divided by 2. Negative 2 plus 4 is going to be 2, and 2 divided by 2 is going to be 1. And then here I've got a negative 6 halves, and my answer is negative 3. So I didn't write my answer over here, but x should be equal to 1 and 2, this first one, and here it should be equal to negative 3 and 1. Okay, hold on here, and we'll come back on the next video. Okay, we're going to go back to that first example.